This video is going to focus on the skills practice for a two-way table and how to calculate the probabilities, especially when you have some blanks in the table. How does this work out? And how do you find the fractions for all the things that they ask you down below? There will be a couple questions on your data assessment test that will have some two-way table information. So if you're needing some extra practice on this, check out my video. The first thing that I want to do is talk to you about how the table works. Now, this is called a row when you go across. These three numbers should add up to be the total that you have here, 106. So if I have three numbers that should add up to be 106, what I'm going to do is take 106 and subtract these two numbers to get the blank missing boys that take the bus number. So I'm going to take 106, subtract 28, and subtract 16, and I'm going to get this missing component here, which is 62. Now I'm just going to check now if I add these two numbers, 62 and 49, I should get 111. 62 plus 49, let's double check that. Yep, 111 works. Now similarly here, these two numbers, the number of boys and girls that walk to school should add the totals, so maybe you want to do it this way. 35 minus 16 should get me the blank here. Should be 19. Now if I want to confirm, I can go across and add these three numbers to make sure that they add up to be 101. So if I take 49 plus 19 plus 33, I should get 101. And then I need to add these two to get this blank here. So students who drive, 28 are boys, 33 are girls. Total students that drive would be 61, and then now my grand total. If I add these two numbers up, I'll get my total, or if I add those numbers up, I'll get my grand total. But don't do this and this because you'll be double counting your students. So 106 and 101 would be 207. This column total or these three numbers should add up to be 207. I'm just going to confirm and check this before I do all the problems at the bottom that I added correctly. 111 plus 35 plus 61 should get me 207. That means I did it right. So this data here, let's just look at it for a second. This is students, boys and girls, and how they travel to school. And what I'm going to do is use this table of information to tell me how to calculate probabilities down here. Now, I sometimes like to draw a line where my total is so I know what I'm kind of looking at. So the number of girls, I have girls that take the bus, girls that walk, girls that drive, and the total number of girls. I have boys that take the bus, walk, or drive, and the total number of boys. But I could also look at just total number of students who drive to school, or total number of students who walk to school, or total number of students who take the bus. And this would be the total number of students that were sampled for this piece of, data collected information. So this is the grand total, meaning total number of just students in general. Now, when you're looking at the questions down below, you need to look for one of two things. Either just one category or two categories. So as you're looking at a couple of these, boys who take the bus, boys who walk, boys who drive, these three kind of go together. Well, out of all the boys, we know there are boys that took the bus, walk, and drive. So these three are going to be based off of these three numbers, 62, 16, and 28, out of the total number of boys because I'm only curious about boys. But look at this question over here. What's the probability of boys that were surveyed in general and girls surveyed in general? So notice there's a difference here with two things being addressed versus only one item being addressed, just boys. And the total for what you're going to divide is going to be different for this out of this question. So I'm going to do these two first down here. Number of boys that we had total, so boys total is 106. But that's out of all of the students. So I just want to know the percent of boys. 106 boys were surveyed out of a total of 207. And the number of girls that we surveyed was 101. So this is going to be 101 out of 207. And now these two, the boys and girls, their percentages should add up to be 100 because we only surveyed boys and girls. So my 106 divided by 207 is 51%. which means this should be 49% to make boys and girls a total of what I was looking for. So I'm just going to confirm here, 101 divided by 207, 49% if I round correctly, that's 0.487. That 7 is going to round that 8 up. So 49%. I've represented all my students in terms of boy or girl. Now look at the difference here. Out of just the boys, who of the boys take the bus? Look at what's going to change here. Boys that take the bus would be 62. But now the denominator for this fraction is not going to be out of all of the students. It's not going to be the 207. It's going to be out of the total number of boys, because I want to know of the boys only who take the bus. And the boy total, my denominator here is going to be 106. Now look at this. Boys, out of those 106 boys, how many of them walk? 16 of them walk. So these are called conditional probabilities because it's based on the condition of being the boy, which means your denominator is going to be smaller than the total subgroup. In these two questions that we have here, there was no condition first being applied. I'm just looking at the number of boys. So that would be boys out of all of the students. Now look at this one. Out of the condition of being a boy, out of the 106 boys, how many of them drive to school? 28. Now let's go ahead and get our probabilities for each of those. Out of 106 boys, if 62 take the bus, that means 58% of the boys took the bus. 16 boys walked out of the total 106, which would be 15%, and 28 boys out of 106 would drive to school, which is 26%. These three, if I rounded correctly, should add up to be 100% of the boys that we were looking at. So I'm just going to clarify that real quick. 58 plus 15 plus 26. I'm off just slightly by rounding, so maybe one of these I rounded just slightly off, or maybe I wrote my decimal down correctly. So maybe what I'll do is just quickly go back and check. 62 out of 106. Should I have rounded that differently? Well, maybe slightly. Maybe that 4.9 is so close that I could have rounded that up to 59%. Because this is a 4, I'm not going to round it, but that could be where my error lies. Now, out of students, just students who drive, I am not looking at a subgroup of boys or girls. I'm going to take out of all my students who drive. The total for driving is 61. 61 divided by 207 is 29%. Girls, out of the girl group, how many of the girls take the bus? How many girls did we survey? The total number of girls is 101. Out of the girls, how many took the bus? 49 of them. 49 divided by 101 is going to be 0.49 or 49%. This 5 is going to round that 8 up. Girls who walked, out of the 101 girls, how many of them walked? 19 of them. This is going to round up to 19%. And then girls who drive, out of those 101 girls, how many of them drive? 33. If I divide here, $33 divided by 101 is roughly 33%. That 6 is going to round that 2 up. Now I have just a couple more. Out of the student who drive, out of the students who drive, who is a boy? Now my subgroup is going to be the total of students who drive. So now my denominator is going to be out of the 61 who drive, how many of those 61 students are boys? 28 were boys. 28 divided by 61 is 46%. Out of the students who, look at this one, drive, Out of the students who drive, who is a girl? These two should make 100% together because out of the groups who drive, right, there were only two categories, boy or girl. So 33 out of 61 is going to be my fraction here. 31 divided by 61 should come out to be 54%. What did I get? 30. Oh, I'm so sorry. That said 33 and I put 31. Let me fix this. Should be 33. So let me redo that. 54%. Nice job. Now, out of the few questions that I have left, out of the students who take the bus, so out of the students who take the bus, out of those 111, how many of them are a girl? Taking the bus is my subgroup, so out of the bus subgroup, 111, out of 111, how many of them are a girl? 49. 49 divided by 111 is 44%. And my last couple questions that I have, out of the students who walk, how many walk? Out of those students, who is a boy? Out of the walking category, 35, 16 are boys. 16 out of 35. %. And then my very last one, out of the students who walk, nothing else, so I just want students who walk the total, 35 out of the general total that we surveyed number of students, 207. So 35 out of 207. 35 divided by 207 on my calculator is 17%. I hope this helps. Reach out to your teacher and let them know if you need more help with the two-way table. Otherwise, feel free to try skills practice B and check the key. And then if you really want to be, a super student, go ahead and try that C, kind of like we would in class, kind of like a quiz, and see how you do. Hope you enjoy the video.